Hi students, let's continue with mutations and what are the reasons of mutations, the sudden heritable changes that occur in microbes as well as in humans. Mutations can be of different types as we have mentioned earlier. They could be spontaneous and induced mutations, and now we are dealing with the spontaneous mutations and what are the causes of spontaneous mutations. Previously, we had discussed about one of the causes of spontaneous mutation, the tautomerism. And now let's deal with the other causes of spontaneous mutations, that is the occurrence of nucleotide lesions as well as the presence of transposons. So coming to nucleotide lesion. A nucleotide lesion is nothing but a gap which has been formed because of the loss of a particular nucleotide. This could occur spontaneously. Now, the example that we have mentioned here is a apurin, that is a depurination or the removal of a purine. And such lesions in the DNA would result in the formation of replication errors and which would lead into mutations. Now, coming to the example that we have here, you have DNA TGGGC, and what happens by a spontaneous reaction, what happens? A G is being lost over here. And so, when this defective strand, which has been mutated, it undergoes replication, it results to one strand which is a wild type sequence and it will be correct on replication on the first round of DNA replication. But the apurinic, the one with the apurinic site would not know what to add after the T. Okay, and as a result, any nucleotide base can be inserted during the DNA replication. Do note that it was a G which was here and we expect a C over here, but instead a adenine has come. So a mutated nucleotide base is being added after the first round of replication. Then when this mutated strand further undergoes a second round of replication, the story repeats and again the mutated one will of course give rise to another mutated strand, and the second one which is having a apurinic site could give rise to anything or any incorrect nucleotide could be added here, and that would result into mutations. Okay, now this is the same with if a pyrimidine is being lost. So whether let it be a apurinic site or let it be a apyrimidic site, what happens, that would result into some errors during the replication and the mutations will accumulate, especially when it comes to the second generation of DNA replication. So let's go to the next reasons of spontaneous mutations. Another cause of spontaneous mutation is the presence of lesions mainly caused by reactive forms of oxygen. Sometimes reactive forms of oxygen, when they strike the particular nucleotide bases, what happens? They carry out certain during the aerobic metabolism, the nucleotide bases gets converted into a different form. Okay. Now in this case, we have an example here. Guanine is converted to 8-oxo-7-8-dihydrodeoxyguanine. And when it gets converted into a different nucleotide base, which is in a modified nucleotide base, what happens? The pairing capacity of it will change. Normally, what happens? G will pair with cytosine. But in this case, after it has been converted into 8-oxo-7-dihydrodeoxyguanine, it starts pairing with adenine. Now here, these are two different mechanisms in by how which this it is getting oxidized. But you need to note one thing. What happens? The GC base pairing is have converted into the AT. Okay, and if it is an AT, normally if it is an AT, what happens? Sometimes it might get converted into a CG transversions. So as a result of reactive oxygen induced lesions, what happens? Spontaneous mutations can result, and as a result, transversions can happen from GZ to AT as well as AT to CG. I hope this is clear, and this would result in the mutations during replication. Another cause that we have of the spontaneous mutation is the transposon. Transposon is known as a jumping element or the mobile genetic elements which naturally occur within this genome, and they are mainly featured due to the presence of flanking direct repeats as well as terminal inverted repeats, the structural features which we will be dealing in a separate section, but I'm concentrating on how transposons will cause mutations. Okay, the transposons, they cause mutations by either inserting into any other gene or promoting various DNA arrangements. And it has been found that transposons are responsible for approximately half of the spontaneous mutations in Drosophila, and it can contribute to various human genetic diseases, as well as the color of the grapes is also been influenced by the transposon activity. So let's go into a brief detail of this. Now, what happens is staggered cuts are made in the target DNA. You know what's a staggered cut? A blunt cut and a staggered cut is different. Okay, a blunt cut is just cutting it through this, but a staggered cut is somewhat like this. See here, like this, it is getting. So, once a staggered cut has been made in the target DNA, the transposable genetic element insert itself into the DNA. This is a transposable element, and the staggered cuts. So what happens, since a staggered cut is there, what happens, this will leave a short single stranded piece of DNA which is blank, and as a result the gaps are being filled in by DNA polymerase, and you get a flanking direct repeats over here, and the replication of this single stranded DNA creates flanking direct repeats, and as a result of it, what happens, you can have a very good notice, a normal gene itself is being cut and a different element is come into it, and as a result, what happens, the expression of the gene itself would be altered. Now, this is the structure of a transposable genetic element or a mobile jumping gene, which its terminal inverted repeats and its flanking direct repeats. The structural details we will be going in detail in the coming sessions. So, what do we have to say is the spontaneous mutations can be resulted as a result of various reasons. Now, for example, we have tautomerism, we have spontaneous lesions as we told, nucleotide lesions, and at the same time, it could also be caused by transposable genetic elements. So, I hope this is clear to you. Thank you.